First of all, thanks to Wix for inviting me to give this talk for you all. Yeah, my full name, Justin Kaeser. I work on the IntelliJ plugin for Scala at JetBrains. Most of the time I spend on build tool integration, namely SBT, more recently with BSP, the build server protocol. And actually, Tomer, we should have a little chat about that afterwards, because some of my recent effort, or my intern's recent efforts, have gone to supporting Bazel more smoothly. But today, unusual for me, I will not be talking so much about build tools, but rather about a tool in the language, namely types. So I want to explore some libraries such as Zio, Zio Streams, Circe a bit, and showcase a bit how some of the tools in the Scala plugin support working with types, understanding types in your program, how they help understanding libraries that you use. So these libraries, I don't have much experience with them. So I want to sort of explore them with you together. So ideally, you'll just, during my waffling around, you'll raise your hand and say, hey, Justin, this is how it works with Zio or with Circe or whatever. So this is how we can do it better. Okay, but let me start now, and you can, jump in, interrupt me, and see what we can get done. So what I want to start with is, I want to just have a quick look at Zio. So I'm going to jump to the IDE share here. So I just have an empty object right now. I also, in another window, opened the Zio getting started, because everyone's talking about Zio apparently one way or the other. So I gotta have my own look what it's all about. So I'll just copy this getting started into my own program. There's a few errors here. First of all, apparently I need to extend zio.app. And I still got errors, but I probably need to import something that's also in the example, zio.console. Okay, so what we see now, we got a few highlighting problems here. This is not a compile error, but what's IntelliJ telling us? Okay, type annotation required for public member. I guess that's good practice. So I'll just use a quick fix, Alt-Enter, add type annotation. And I actually get two examples here, two ways I can auto-complete it, either with Zio zenv or with console. So console seems to be the more specific one here. So I'm just going to use that. Okay. But I wonder what that actually is. So I can do like quick documentation, and that gives us some information. So it actually gives the type definition, type console equals has console service, whatever that is. So why don't we just have a quick look at it? What's a has? And here we get a bit more definition. So there's a map and a cache. Okay, I'm not gonna look too deeply into that. Another interesting thing here is the URIO. What's that supposed to be? And here again, we can do like a quick doc by hovering over it with command button in my case. It gives you the URIO is a ZOR, nothing A. And I'm just going to navigate in there and see, okay, we got all kinds of types. So I'm guessing ZO is some kind of IO monad-y thing, right? So has allows to compose injected dependencies. And that thing goes into the first slot, the R here, which I read stands for requirements. So this program requires a console. And that's what we see down here. The my app logic also has this inspection type annotation required because this is a public member. I'll just autocomplete it here. So this gives us a bit more information. It has a R requirement of a console. The second part is an IO exception. So I'm guessing this is the error type. And the last is a unit. I'm guessing that's the result type, or how would you call it? Okay. So I've looked into that a little bit now. So yeah, because this is a unit, I'm guessing this thing just is used for its effect or side effect of putting a strlen, getting a strlen, getting a line, printing something. Okay. So I've prepared a little bit of things. So one little project I wanted to look at was creating a kind of JSON RPC client in Scala or client server implementation. So I thought a nice way to do that would be with streams. So I looked a bit into ZO streams, but first I'll show you a bit of define some data types. So in JSON RPC, we have notifications, requests, success and error responses. Pretty simple, but these take some kind of parameters, which are optional. So I've modeled that with just these simple case classes. But so how do I start here actually? I've created a client server Scala, and like in the examples, I call it a zo.app, and I'm getting an error here. So what it's missing is the zinf exit code. Yeah, the run method. So I can just automatically implement that. And that already gives me some idea of what I need. So I've looked this up, of course. One way we could create a server is from some kind of input stream. For now, I'll just use a Z stream. Import from. So now we have all kinds of options really, and a lot of from methods. And I want one that gives me an input stream. So I just look for one that uses an input stream or something like it as a parameter. From, and luckily it's also named conveniently. So yeah, some people say names don't matter at all, but they do make it easier to find stuff. But here we can also And for this actually does take an input stream and some chunk size parameter. And for now, I'm just going to use system.in. So this returns a Z stream, which is, but we need a URIO, which is some kind of ZO object. But maybe there's already something that can turn this into a ZO object with an exit code. No, not quite. It doesn't seem to. So looking through all the types here, all the types on the right side of the Z stream, that doesn't seem to be quite what I'm looking for right now. So instead, I'm gonna try to find out how I can consume the stream and turn it into JSONs, parse JSONs. So this has all kinds of stuff mapped chunks. So one thing with the ZO streams is it uses some kind of chunking so that we don't have to deal with individual bytes, for instance. So map chunk sounds kind of nice. Okay, so basically I'm gonna pretend these are arrays. Now I looked into John before, and it actually has a way to parse individual bits and only return finished JSON when it receives enough. So now, well, damn. Now I kind of forgot the part I wanted to do. I'm gonna need John Parser. So I'm just gonna put this here inside the run method. Supposedly what we're actually supposed to do in ZO is wrap this in a resource or something. So import jparser async parser. So this has a few modes, which the autocomplete helpfully helps us. Actually, let's try something here. The SmartCompletion, that's shift control space in my case. SmartCompletion gives you something like typed holes. Basically, it looks what kind of type fits into this place, like in this parameter slot, and looks for values that have that type. So in this case, this is very convenient because there's only a few such values. And namely, there's async parser value stream, single value, and unwrap array. It also gives you these very generic functions, value of, which gives you a T, or unsafe run, which gives you that's probably not super helpful in our case, but it does find the ones that are helpful. So yeah, if you've heard Haskell fans talking about typed holes, we got it in Scala and IntelliJ. So I'm guessing a stream is what I actually want here. And I'll just call this one parser. So chunk parser, and parser can absorb strings or byte arrays or byte buffers. And I guess we can turn a chunk into one of those to array. And this gives an either a parse exception or sequence of J values. So ideally, I'd like to use this output to map this either into the Z stream. So I'm probably looking for something that gives us, that handles the error or gives us a sequence, handles a sequence of these J values. So maybe we can find another function, and indeed there's map chunks M, which just take it, which instead of mapping two chunks directly, maps to a ZO of a chunk. Okay, but that doesn't fit our type yet. But we can fix that. So this is an either, so match is a good thing to use. So we actually have this, when I write match, I get this option to match exhaustive, and I get all the possible values. This works for any sealed classes for sure. So left value, what's this type of the value? It's a parse exception. So I'm looking for a ZO that takes an error. I guess this one will work. And here I want a ZO that succeeds with a value. This is a seek, and we need a chunk. So how do we turn this into a chunk? Is there any implicit that might do this by any chance? I'm just guessing here. It's probably not. Okay. So I can select this to actually tell me what type I have. Z stream blocking exception J value. But as you see down here, we've got this convenient type error. So the Scala plugin tells us the type error by just showing us the type that we have instead of the expected type. We can also hover over it here. Or can we? Required URIO. Okay. But we have a list of J values. But so for now, I just want to output these things. So for each looks just about right. It takes a J value and takes another ZO. So we can't just use println. But we saw in the example before, we have another ZO native thing, put stir ln. We probably need something here. ZO console put stir line. So, and I can just put this here dot to string. It seems to probably work out. This put stir line, so this is defined in where? In this console service thing, which it, and it returns a UIO. And here we can look at the definition again. UIO is a ZO any nothing to A. Or is it? Yeah. In this case, it's a UIO unit, so it just has a side effect. And the question is, why is this available? I'm guessing it comes through, yeah, where does it come through? Do we actually?
The zo.znv, line 12.
Yeah, right here. So this, thank you. This has all the standard environments, I guess, in it. Okay, so this still gives us a type error because we expect we have a ZO, but we expect a URIO with an exit code. Let's see if there's a helpful function here. Oh, indeed, it automatically gives me .exit code. And you see here in the type already, this has console URIO console exit code. And that is compatible with the ZN from either. And then we just put this thing in here. No. Yes. So if we take this out, it's still gonna IO parse exception seek J value. But then we still gotta turn the thing into a chunk, right? Can we do a map?
Yeah, sure.
Yeah, map seek. And then we do chunk from iterable. That should give us the type we want, right? Thank you for this hint. So,
no problem.
And by the way, another nice type feature you see here now that we have more than 2 or 3 lines in the sequence of things here. You see on the right side the type of the line or of the invocation. So we go from ZStream blocking IO exception to ZStream blocking exception J value to ZO console exception unit to URL console exit code. So you actually see what's going on, what transformations you're doing. I find that feature pretty damn helpful. So like, otherwise you could still find it out by like selecting the part and doing, on my keyboard, it's Shift-Control-P and you get the type here. But like this, you see it all in one. So, okay, this is some kind of server, but now I want a client. So I'll just make another ZO app. And have IntelliJ auto implement the run method. So, okay, how's the client supposed to look? The client will need different parts. So I'll have a command line client where you can send commands that get sent to the server and then hopefully get a reply, or the current server will just print out the things that it gets sent. So where do we start? I guess we'll start with another ZStream. We have different things here. repeat effect is offered right on top. That sounds kind of good. I want to read something from the command line and have some kind of effect. So I'll just do this. So reading something, we also have that in the initial example. Was what, get stir line. And we could just repeat this. So what's the type of this? A Z stream of strings in the end. And I kind of want it to be a little more looking like a command line. So I'll do a put stir line, do this command line arrow. And then I just kind of want to, this is another ZO thing, a URI IO, and I just want to thread these. So can I just do map, get stir line? Not quite. What's wrong? What parameter type does it take? A unit to be? No, we don't want to be, we want a ZO map effect, maybe. Would that work? No. It should take a ZO, right? Can we use that? It is a ZO and it returns another ZO. So we do a flat map. There we go. Okay. Now I have a thing that still gives us a string. And I kind of want to turn this string into a JSON request. So it's probably just another map, right? And I prepared some toy data thing here. Simple notification. Def simple notification takes a message, gives you a notification string. So toy data. What's wrong? Need to import. Simple notification. There. Done. So now we have a stream of notification strings, but those are not really JSONs, right? So I do another map, and I happen to know that the Circe library, which I already imported, has a JSON method that can be added implicitly. This is red, but luckily since 2020.2, IntelliJ Scala can just import such implicit conversions. But it's telling us it's still missing something. It's missing another implicit. And I can also press Alt-Enter again, import implicit. So now we can just find implicits by the types, essentially. IntelliJ Scala does it for you. So you don't need to look it all up in the documentation, what exactly you need to import. You get a whole array of things that you could import, conversions that would work. So I did look into the Circe documentation, and I could do fully automatic derivation of encoding. So I would just import IO Circe generic auto or something. This is not included, but all the more specific ones. Oh yeah, IO Circe generic auto export encoder is actually here. Let's see if that works. Okay, gives us a JSON. I want to format this a little better. Auto indent. Great. So for now, we can just check if this actually encodes something useful. So we do a JSON and yeah, we need to do oh right, sorry. JSON dot, so space is 2, presumably pretty prints it, and we need a actual effect put stir line. There we go. And do the same exit code spiel here. So I'm just going to check if this client outputs anything useful at all, or sort of what I expect. I do a build. Should have pre-compiled it. There we go. Hi. Okay, it creates a nice, pretty JSON. So now we want to connect the client and server. So one way to do this would be with sockets. So again, here I'm gonna cheat a bit and not define an environment, and instead just do a, how do you define a socket? Java.io.socket. Well then, I should have written this down. Oh yeah, java.net.socket. I think we do a new JavaNet socket, and what kind of parameters does it take? So yeah, another nice little type feature. We just press Command P and see all the possible parameters that this could take. Let's see if we can do something helpful here with auto-completion. No, not yet. But I guess we just need a host, which would be localhost, and a port of just 43211. Is that in the valid port range? Probably not. I'll take 13211. Okay. Socket dot connect. Oh. Do we have to do anything? It's been a while since anyone's used socket, huh? Okay. Maybe this is already enough. So what I want to do is, besides print it, is to lock socket dot right.
Maybe get output stream, maybe.
Oh yeah, get output stream. write JSON dot can we turn it into a byte array directly? I'll use no spaces, get bytes, UTF-8. You probably want to wrap this in some kind of effect, right? Can we do a ZO? What does this actually do? Synchronize side effect into a pure ZO value, translating any thrown exception into type failed tests. Add type failed effects. Sounds good. I'll just put this in here. And oops. And on this other side, we'll need a server socket, right? Server socket, port 13211, socket socket. Socket. What's wrong? Oh, yeah, server accept. And we want to actually, yeah, instead of the system in, I'll use socket get input stream. Okay. No idea if this will work, but let's try. I'll try to run first the server here. And client. Hi. Look into the server, and indeed, they are connected. So that socket thing kind of worked out. Cool. So I think I showed you most of the features, but let me go through my list. So we have a type of selection. I'll just do a quick recap. So one, you can do type of selections. So just select whatever expression, the type you want of. And depending on your keyboard layout, for me it's Shift-Control-P, and it will show you the type. There's a little annoying thing here. It doesn't ignore the white spaces. So if you select extra white space and press Shift-Control-P, it doesn't work. One day, I'm sure we'll fix this. So you saw when the return type doesn't work out, we get a type error highlighting here that shows you the type you're actually returning. And in the status bar, you'll see there's what exactly is required. So there's a mismatch. It's required a URI with exit code, but This is a ZO ending in unit. So you've seen parameter type hints. So when we go into socket, you get all the possible, and press Command P in my case, you get all the possible parameter combinations. You've seen how we can, you've seen smart type completion or type tolls. So that's shift control space, and you get possible values that can be inserted in the type that is expected at the point where your cursor is. You've seen some implicit hints. So if I go and remove the Cersei stuff here, where is it here? So you get implicit imports automatic just by pressing Alt-Enter, and it offers to import implicit. You get implicit hint error messages. I don't know why the hovering is not working. Usually it would also show on hover. But anyway, you also see it in the status bar. So no implicit arguments of type encoder. And also a quick fix with Alt-Enter and a list of possible encoders in this case. So implicits that will solve this problem. Boom. One thing I haven't showed you maybe is type hierarchy. So if we go on some type and press Control H, okay, this is not so exciting. URIO also not exciting. That's more useful if you have a class hierarchy. So I gotta find one that is more in a hierarchy. So like if I go in ZO, we have different ways here. So you can look at the class hierarchy and the supertype hierarchy. So in the case of this package object ZO, which extends a bunch of stuff, you'll see here that all the things that it extends from. I find this most useful if something has a deep class hierarchy and or there's various implementations of a certain class that are strewn all around the project or the dependencies where you don't immediately know what implementers there are. Typically, Java interfaces work like this. And you see right here in front of you the stream type hints. So for each line, it shows you what result type it has, even though it's all one big expression. There's some nice inspections, like you've seen the one with, where is it? Doesn't matter. You've seen this one. So first of all, it will just automatically show you in a type hint the return type, but also offer you a quick fix to add this annotation and the particular type you want it in. A more specific type I'll choose now. I've showed you SmartCompletion. And another helpful one is actually if you want, if you have, say, int and you want to compare it if n equals 2. This will get highlighted as a problem because you're comparing unrelated types, int and string. In this case, maybe more obvious, but say if you used a character here and you wanted to check if n is the character opening brace, that would be a bit tricky one, but the Scala plugin will find it for you. In Scala 3, this is, I believe, actual compile error, but in Scala 2, this is a very easy to miss error. So comparing unrelated types. So now we can fix this and it will not highlight as error anymore. Okay, I think that's it for the main part of what I wanted to show you.